minute, right? Okay. We can do this. Okay. This is actually my favorite. This is my favorite topic. It's my favorite section. Okay. So, I'm really bummed, you guys aren't, that we're not going to do this assignment, because those web pages that I had you read are gone. Yeah, and they were still on this page, right? Yeah, I'm really bummed about that, because the Nobel Prize had these, and they had, like, if you guys are in A&P2, they had this awesome blood typing game. Like, it was awesome. So yeah, I already emailed them and complained. But apparently they don't care, because they haven't emailed me back, and that was like a week ago. So I tried. Maybe I'll give y'all the link and tell y'all to email them, because if you're in A&P2, you want that game back. Trust me, you want that game back. The web pages, I'd be happy for a copy, and I might actually find a copy somewhere on my old hard drive, so I'm going to look when I get a chance. But I'm just not going to give you that assignment. This one you guys are excited about when I click turn on, because what does it say? Bonus. This one says bonus. You see that? It says bonus. What this one is, I've done something like this before, but this is some videos of me in a classroom before I had the fancy classroom like this one, and apparently my other one in the other building has been converted to having the cameras, but I wrote on the boards, right? So you'll see here, because I had said to my students before, I was like, draw it out, right? And y'all looked at me like I was a crazy person. So I literally, like, you can tell this is years ago, right? Look at how beautiful I am. But I literally drew on the board and explained out some of these processes, and one of my students literally videotaped me, and I posted it on YouTube. So there are like 5 videos, because you know my camera was a sucky camera, but that's okay.
How old is that video?
It's old. What does it say? 2015. Yeah. But what I want y'all to do is see how I'm drawing out on the board and how I have these cells drawn. And you see, I'm not the best drawer. This is not about what it looks like. It's about the knowledge, right? And sometimes when you write stuff out, or in this case, draw stuff out, then you're going to remember these steps and these processes and these cells. So just as I'm writing on the board, and it doesn't even have to be color-coded, I want you to draw out what I draw on these boards. And then either take pictures of it, and you can see in the assignment that, well, I'm not in my student view. Let me do that. You can, I didn't click student view yet, did I? Huh? I'll get there. In student view, you have to hit submit, right? And then it gives you the ability to upload files. So you guys are all fancy, right? You use your cell phones for this stuff even, right? You know how to take pictures and upload files. If you're one of those people that don't fall into that category, that's fine. Whenever you do that, whenever you do these drawings, bring it to class, show it to me, and I will give you your points, right? All the way up to the day of the exam, which is the 29th, which will be here before we know it, right? 7 lectures. Bam. Test, then finals, right? And we have off 3 days for Thanksgiving. Wednesday, Thursday, Friday, right? Tuesday we will have class. Okay? So, so that's there, but this kind of is some of the later stuff. So notice it talks about B cells and the action of antibodies. This is actually the last stuff I cover. This is kind of towards the beginning stuff. But do this at any point, and then maybe watch them again later, right? But these are really going to help you out, right? Especially those of you guys that are visual learners that learn by writing, which is why another reason, like the homework that I gave out, and I know a couple of you guys don't have it and maybe had to print it yourself, because I numbered the number of copies I laid out, and I still had extras. But I had posted it for you, I think, right? leave my student mode, right? So I had even put it in an announcement, the homework, right? So there's the PowerPoint that I printed for you, right? But I'm going to have it available in the modules like I usually do. And I even linked the 2 YouTubes. These are my probably my 2 all-time favorite videos. And because we're getting short on time, I'm not going to play in class, which is why I really wanted to assign them for homework. And I might still go back and assign them and have you watch them and actually do a submission, since the web page one is gone. But I hadn't done it yet. But don't be surprised if I don't. If I do. Because these are really good. This one's pretty awesome, right? Because if you did your homework, you know what I'm talking about. That you literally see this is in a mouse, right? So it's probably ultrasound, right? And this is literally white blood cells in a blood vessel rolling. It's pretty awesome stuff. So related to inflammation. So although I gave you the first one, I haven't given you the second one. I wanted to make some changes to this, but I know some of you guys, it bugs you when you don't have in front of you what I'm talking about. So I'll go ahead and turn on that page, but I want to make changes to it. This one. Objectives. And that. So this one. Alright, so this is the PowerPoint I printed out and handed out to you. This is the one with the answers revealed, hence the R, revealed. And this has happened to me before. It keeps happening. So at this point, I think some of these follow the adaptive sections in your book. Like part 1 is part 1 in your book. Part 2 is part 2. 3, there's 6 sections. So like I literally did my PowerPoints like that. But some of these we're going to skip over and not go over. Hence why this says new, because at that time it was new. I keep getting short of days, like something frickin' happens. So I'm probably just going to change this to we're never going to cover this material. I'm never going to have time. Because it's the end and something always happens. Either I get sick or we miss days or both things happen, and that's life. They just don't give us enough days. So these are some of the videos too, and I just want to clean up this page, but I'll turn it on for you because I'm going to cover 1 today, and I'm going to start covering 2 as well. So if you're like one of those ones that like to have it in front of you right now, you might want to download 2. I would have printed it for you this morning had I not been at the hospital. So I need to download them myself because I don't have them on this computer. So I'm going to do that. And I'll save them to this computer too. So we will do Innate Part 1. And again, I put these blocks here so hopefully you would read ahead of time, which is what you really should do. And so that, well, I'll save it after. I opened it, I just can't find the one I want to click on. That's it. To try and encourage you to read and write, right? Read ahead of time, write ahead of time. For this module, it is of utmost importance that you do that, right? Maybe you didn't do that the first 2. Maybe that showed on test 2 grade. I don't know. Test 2 kind of sucks. I don't know. I actually don't even ask you that many high order questions. A lot of lower order memorization type questions. Maybe y'all would do better if I gave you harder questions. I don't know. I don't know that mystery, but we're not going to talk about test 2 until Thursday when more people are here, and I'll even do a recording on it. So this first chapter, there's 2 chapters, right? So you think, oh boy, this test is going to be easy, right? No, we're going to cover just about, right? But as I already pointed out, not all, but just about all the material in these 2 chapters. And sometimes this is new stuff for you. Although nowadays, this is becoming more mainstream knowledge, which is awesome, right? So more people know about immunity and immune system. So that helps us out, right? So we are constantly, right now as we're sitting in this classroom even, we're bombarded by microorganisms because remember, they're in the air we breathe. You can't avoid them, right? They're on our hands. We ingest them in food and water. No matter how clean it is, trust me, you're doing it. This is the part of the class where, you know, y'all really start hating me because I make you a microphobic person. But please don't, right? Resist that want to be scared of the world that we live in, because we have this beautiful immune system that we're going to talk about, right? And your book and most microbiology classes are going to divide the immune system into two major topics, the innate versus the adaptive. And there's two reasons for this. One, as you'll read about, if you haven't already, at the end of the adaptive and innate chapter, actually, in vertebrates, which is not us, right? We have a vertebrae, right? Lower order animals, you can kind of say, do not have an adaptive immune system. They just have innate. Although as we continue to study, you know, they've got some things that, you know, could fall into the classification or definition that we give to the adaptive immune system. But as the word innate implies, right? Anyone know another name for innate or what that means? Natural, right? We're born with it, right? So we naturally have this, like, you're in utero, you even have this ability, right? Even parts of your adaptive immune system you have, right? It comes pre-programmed in your DNA. Adaptive, that word, when you say something like adaptive, what's a synonym to adaptive? Or what does adaptive mean? Acquired, you adjust, it changes over time, right? This one gets better, right, as we go on. And it has to do with how these systems work. But the important thing, and where people get confused sometimes, is because we kind of talk about them separate, they think of them as two separate entities. Not true. Instead, think of it as innate is the foundation, right? And adaptive is the add-on that you can get, right? The upgrade on your vehicle, right? We get the upgrade version, right, of the immune system. We have innate and adaptive. Does that make sense to y'all? Because that's a really important point. Okay. All right. So, what does immune mean, right? It means resistance to an infection and subsequent infection, right? So that means that either you can't get the infection, like the first example we'll go over, or because you've been exposed to it previously and survived it, your immune system can fight it and eliminate it before you even get sick, before you even know it entered your body. How awesome is that? All right? You can see, I love this system. It's so cool, right? So one way is passive resistance by nature. So, for instance, dogs don't get HIV because what does HIV stand for? Human immunodeficiency virus. Is there a deficiency in virus that affects dogs? Yeah, it's just called something else. Okay? The important here is the human component. And we talked about this before, too. Right? This is kind of review, because guess what? Comprehensive final exam, I'm sorry. Departmentally required, but not departmentally written. You can thank me for that. Okay, so why is it? Right? What's the first thing that needs to happen for a viral infection? attachment. That virus must attach to our cells, right? So human cells obviously have slightly different receptors on our cells than dogs do, right? Hence why human immunodeficiency virus only infects humans and monkeys, which are our closest relatives, right? Which is where they believe it came from, evolved from. Okay? Dogs don't get human immunodeficiency virus because their receptors are different. And then we also talked about that tribe in Africa, right? How even there are some humans that won the genetic lottery and their receptors are different enough that the virus doesn't attach to them. Okay? That's all great, well, and fine. But those are rare instances, right, of being immune, passively being immune, right, where the thing just can't recognize you, can't attach to you, can't cause problems, okay? Viruses aren't the only thing that makes us sick, right? Pathogen means something that makes us sick, right? So all the rest of them are things that they get in, right, and our immune system has to mount a defense against. You get sick if things don't work, right? But let's first talk about what are some pathogens. So viruses we've already mentioned, right? What else? What's the big number one that makes us sick everybody knows about? Bacteria. What else? Huh? Fungi, funguses. Algae don't make us sick. There's one algae out there that produces something that can make you sick. Anyone know? Red tide. And what does it produce, though? Nope. A toxin. Lots of bacteria do that, too. So, toxins are harmful to us. Can cause disease, right? What am I forgetting? I don't know. Oh, protozoa. Things like Giardia. And then parasitic worms, which we don't really talk about in this class, right? But all of these things, right? Cancer cells, right? Our own cells behaving badly, right? All of these can cause disease, right? Bacteria, fungi, parasitic worms, protozoa like Giardia that we talked about way back in the beginning, right? Viruses, toxins, whether the one algae that does it or a whole bunch of bacteria that produce toxins. And your own cells behaving badly can cause disease. But we also know that some viruses can even cause our cells to deform and become cancerous, right? So for the most part, foreign agents, right? But cancer sometimes can be a within problem. Okay, so if we have defenses against all of this, right? Why is it we still get sick?
Because it's always, the RNA viruses are always changing.
They're changing, okay. So that's one thing. The organisms mutate, right? They change. If you have a defense system, so the easiest way, and your book talks about this too, to equate your immune system to our everyday lives is think about your house or anything else that we try to protect with alarm systems, right? Or with barriers, right? Some of us have fences. I used to have an awesome dog, man. I'm telling you, he scared me even, right? We have alarm systems, right? We have all these things that try to protect our valuables, right? Okay? Which wouldn't be me, by the way. Remember, I'm a teacher. Okay. But don't bother breaking in my house. I got another dog. She'll lick you to death, though. The other one would have probably, attacked. So we have these, right? We have maybe a fence, a scary dog, right? A neighbor that is retired and stays home all the time and calls the police every time she hears a noise. You may have an alarm system that goes off in your house that alerts the police that will come, right? All these things, right? Does that mean that you're not going to get robbed? Absolutely not, right? Because they could hop the fence, kill the dog, dismantle the immune system. The landlord is actually out that one day, right? She went grocery shopping, and they steal your stuff, right? This is why we have renter's insurance and insurance, because it's going to happen. So think about this as far as it relates to your immune system, right? Is there ways that some of the bad guys can get past our skin? Shoot, if you're anything like me, I cut it daily, it seems like, right? Okay, so that's one barrier that gets breached all the time. Whenever we have a cut, right? That basically says, okay, go ahead, come on in. Okay, then we have openings, right? Otherwise, we'd look really scary, right? With no mouth, no eyes, no, right? We have openings where the stuff comes in, right? Like I said, we breathe it in, right? So, oh my God, it's gonna get in, y'all, right? So even if we have barriers, there's some barriers they're gonna get past anyways, right? They're gonna get in. So once they get in, of course the system, we have ways of alerting to the fact that they got in sometimes, right? Can they evade that? Some of them do, right? Some microorganisms evade detection, right? Just like the damn burglars, right? Some of them, too, even overwhelm our system. I won't talk about the police department. They won't like me then. They definitely will never come. Okay? But, you know, right? So these are our answers, right? They evade, and they even destroy parts of our immune system, like HIV does, right? It destroys our immune cells, hence why it causes immunodeficiency, right? And they can overwhelm us, right? That's why we still get sick, right? Because microorganisms, some of them have these abilities. This is why they cause disease, right? They get in, they destroy, right? They overwhelm us. So what are we going to talk about? How they do this. Sterile versus non-sterile. So this question, which I forget where I got it from, but it works good to really kind of test your knowledge then, right? So sterile, when we say sterile, what does that usually mean? Don't even look at any of our questions yet, or statements. No pathogens, no, right? So if you have like a sterile media in lab, right? No bacteria, no viruses, no nothing in it, right? Nothing that can hurt you. You could eat it, even, and you would be fine, right? Okay? So that means gone, right? Non-sterile, of course, is the opposite of that. Means that something is there, right? So let's read through. We're going to read through each one of these and see if we can see if it's sterile or non-sterile. And which one are we looking for? Only one of these is going to be an example of non-sterile. Okay? And there are clues in each one of these statements that let you know whether it's sterile or non-sterile. So the complete destruction of the measles virus by the immune system response. Sterile or non-sterile? Sterile. What was the clue there? Complete destruction. Right? It's gone. Right? And that's what sterile means. It's all gone. We got rid of all of it. None of it is left behind. The removal of a toxin from the body by a specific antibody response. Sterile or non-sterile? Sterile. What's the clue? Removal. Right? It's gone. Preventing the spread of Mycobacteria tuberculosis by encasing them in tubercles in the lungs. Sterile or non-sterile? Non-sterile, they're still in you, right? We're just walling them off to try and contain them. Says nothing about killing or removing, right? That's the non-sterile one. And that happens with some diseases, right? Where we can't get rid of it. The herpes viruses, they incorporate into your cells. Once infected, always infected. Chickenpox is a herpes virus. Once infected, always infected. Even if you get the vaccine, they're giving you the virus. Right? And so, of course, we know the rest of them are sterile, but let's still read through them. Okay? So, immunized against the polio virus for the development of a quick immune response to destroy the virus. Sterile. What's the clue? Destroy. But what's interesting here? We prime the immune system. We immunized you. We basically gave you the wanted poster. We gave your immune system, we're like, this is what the bad guy looks like in a weakened form. Get ready in case he comes. And guess what? He came. And what did we do very quickly because we knew ahead of time what he looked like? Destroyed it. Right? The immune system, right? Immunization takes advantage of the adaptive part of our immune system. This ability to remember, right? I used to live in a bad neighborhood. We used to get those little sex offender postcards all the time. I literally had them posted by my door and looked at them every time before I walked out the door when I lived alone. Right? It's not cool. But it was, so I remembered what these people looked like. So if I saw them, I went the other way. Right? It was a very good warning to like not interact with that person. Right? If they were nice, hey baby, I was like, see you later. No, thank you. Not interested. Right? So immunization, right? All I'm going to say about that, y'all, is please really listen to what we talk about in this class and think about that as it relates to people or yourself if you don't want to do immunization. And know that there's been a lot of research and a lot of lives saved and not hurt by immunization, right? So I'm talking about anti-vaxxers, right? And if you're one of them, come talk to me. We'll have a nice long discussion. And I hope to change your mind. Desperately hope to change your mind. Okay? But, we could spend an entire day talking about it. And we're not going to debate that. Right? But know as a scientist and as a human being, I get my vaccines and I give my child his vaccines. I even gave him the Gardasil vaccine because God only knows what he's going to do when he gets older. Right? You know what that one's against, right? HPV, human papillomavirus, which has been scientifically linked to cervical cancer. Right? Can boys spread it to girls? Yes. Are they asymptomatic? Yes. Do I want him to not get that disease and pass it on to some lovely lady someday? Or gentleman, doesn't matter. I don't care who he likes. Right? No. Right? Okay. So, immune recognition and destruction of the rhinovirus strain to which a person was previously exposed. So again, this is taking into account the adaptive immune response, right? So you had the infection. Rhinoviruses are all those viruses, y'all, that cause what we call the common cold, right? So, and that's why you're like, damn it, why is it that I got a cold, right? And yet I keep getting a cold, but we're going to talk about an adaptive immune system that remembers what we're exposed to. Guess how many different rhinovirus strains there are out there? Yeah, like over 100. Okay? So you may have been exposed to one, and you're not going to get that same one again if your immune system remembers it and does like this and takes care of the problem and eliminates it. But if you get somebody else, right, you're going to get sick again, right? And of course, they also, what, Terrence? Constantly change. Yeah. So. But this is sterile because what's the clue here? Destruction, right? They recognize it and they destroy it, right? That's sterile immunity. We got rid of it. That's the good news, right? So what are the key features of innate versus adaptive, right? So immunology, of course, is the study of the components of our immune system, right? And really how this system works, the important thing for this to work is being able to distinguish between foreign substances and self structures. And again, when your cells are cancerous even, this is not normal, right? So you could almost even say foreign abnormal versus normal self. We can make it even more specific. So then these are two definitions I'm not too fond of, so I'm going to make them a little bit better for you. typically people refer to as the innate immune system as being non-specific. And the adaptive is being specific. You're going to laugh, right? I just laughed at myself. Because, okay, what do we mean when we say specific, right? To what level of specificity, right? So to give you an example, right, so that this makes sense, how specific is the adaptive? It is down to the molecular level specific, where we're talking about strains of bacteria like E. coli 0157. That's a pathogenic strain of E. coli, right? And it has a very specific sugar structure on its coat that denotes the 0157. The bad news about the bacteria that has that coat, right? And E. coli is gram-negative, right? So this is in its outer membrane. It's part of its LPS, the lipopolysaccharide. It has acquired a toxin called the Shiga toxin. He probably got it from his cousin called Shigella, right? And we know about them sharing information, right? We talked about this. This is transformation and transduction and conjugation, right? That's probably one of the ways that he got it, right? But right down to that very specific level, our immune system, and the big key identifiers for your adaptive immune response are antibodies, right? And cytotoxic T cells. Because they have receptors that are literally molecular receptors, right? So we're talking about molecules recognizing little tiny molecules. So when I say specific in this case, for adaptive, it's very specific, right? Right down to like 10 amino acids specific, or a few sugars in the case of E. coli. So when we say non-specific, it's not that specific. So it's more like, okay, it's a bacteria, right? That's all the innate can announce, right? It's like, oh, it's a bacteria. Or maybe it's a gram-negative bacteria, or gram-positive. Or it's a fungus. Or we're dealing with a virus. That's the level of specificity that you deal with innate, right? It's broad. Yeah, it's broad. But again, the two systems work together, because you're going to see we're going to need parts of the innate, which is really the first line of defense, right? And part of theirs is that detection. Oh, it's a bacteria, right? Oh, it's a bacteria I can't handle. I got to call on the adaptive immune response because I need help. Because I can't handle it, right? I need some more specific help. I need to go to the next level. We need the add-on. Right? Innate is what keeps you alive until adaptive kicks in if it needs to. Right? If you haven't primed the system with immunization or prior exposure. So we're going to repeat a lot of this stuff, right? So hopefully you get it. So as I said earlier, right, innate is found in all multicellular organisms at birth, right? Innate means you're born with it. You actually have it before birth, right? But where it really counts is when you're born. Actually, in the process of even being born, you're being assaulted by microorganisms. It's our first line of defense, as I said, right? This is what we need, right? When they get past those barriers, this is what we need. This is the alarm system that's going to go off. And even attack, right? So they usually recognize biochemical differences between microbes and host cells. While microbes can be recognized as foreign, right? Different. The system can't discern the previous identity of the microbe, right? So again, this system doesn't remember. It'd be great if it remembered, but it doesn't. It simply responds to an entire group of similar microorganisms in the same manner. That's why it's called non-specific, right? Adaptive, which is the next chapter, is only found in vertebrates. So it's the add-on. We've got it. Works with the innate. But this is a stronger level of defense, right? Like this is the add-on. This is going to the next level. It recognizes specific pathogens rather than the broad classes, right? So right down to E. coli 0157. The response is mediated by molecules that bind to this specific pathogen. So these are receptors. So these are antibodies that the body produces or T cell receptors, right? This is a molecular interaction. Not to say that innate isn't molecular too, but this is very specific. After the initial exposure, what's really awesome about adaptive is it remembers it. It has a memory component to its response. So when you're exposed to it again, it's that memory response that kicks in. Okay? And that's what immunization allows us to do. It allows us to very safely do the initial response, the initial exposure, right? The warning. And so then whenever you see it again, we're dealing with memory response, which is faster. You know this, right? Right? If anybody's ever studied martial arts, right? How do you know how to block so quickly? Because you've blocked 8,000 times before the time you really have to do it. You practice and practice and practice. So when someone throws that punch, you block without even thinking about blocking, right? It's all muscle memory at that point, right? For the immune system, the same thing. They've built up a whole fleet of memory cells, right, over the years. So let's talk about our barriers now, right? So you've got skin, beautiful skin, and it itself is a multifaceted barrier, right? It's cool. Do microorganisms like cold? Not usually. It's relatively dry in most areas. It is also tends to be acidic. These are all things that are not conducive to microbial growth, right? So the skin itself, not the best place. It's covered in a layer of dead cells, right? So this basically creates an armor, right? Because again, dead cells are just that. They're dead. They're not useful, right, usually. And we shed them off too, right? Most of the dust in your house, unless you actually have real dirt in your house, is your dead epithelial cells that you've been shedding. Yeah, I know, it grosses you out. It's what the dust mites actually are eating, by the way. Yeah. What do bacteria actually like, and why is it that they can infect skin? Is the sebum. Some microorganisms have adjusted to that oily substance, the sebum that we produce, right? They can eat that. But others, it is antibacterial, antimicrobial. Okay? All mammals produce this, like us, right? Because this allows the hair to slide out of the hair follicle. You are covered in hair from head to toe, whether it's little tiny fine hairs or big beautiful hair. It's part of being a mammal, right? Part of that, you would be screaming all the time as your hair grows if it wasn't for that oil that helps that hair slide out of that follicle. You sweat, right? And sweat is what? It's salty, right? And we know salt, too, is antimicrobial. It also helps probably with convection, which is why our sweat is salty. It helps with the convection to help us cool, right? And then you do actually have, right, every single one of you, if we went into the lab, you touched your hand onto a plate, even right after you washed your hands, right? You're going to transfer bacteria from your skin onto that plate. We all have what are called normal flora, normal microorganisms that do colonize our skin, right? Bacteria and fungi. They're normally there. That's actually good news, because we've kind of like have this agreement with them. They're like, okay, you can eat our extra stuff. You can have a place to live, which is on us, but you're not allowed to harm us. Okay? And they don't, for the most part. It's a symbiotic relationship that, goes really well, as long as they stay where they're supposed to, right? Some of these become what we call opportunistic pathogens because they go where they're not supposed to, and we don't have an agreement there. Okay? The good news with these guys, though, with them being there, is think about it. They're eating the food source. They're taking up the spot. Is there any place for the bad guys? No. So when the bad guys come along, they got to keep moving along because there's no food and there's no spot. Or they've got to fight the ones that are already there for that spot and for that food. Right? It's kind of like Delgado at the beginning of the semester. You got to fight for the parking spot because everybody's here. Right? You got to come early. That's why I don't mind early classes, because then I get a parking spot. Make sense? All right. So there's our beautiful skin, right? And the other really great thing is that other than, the dead layer, the skin itself, the deeper layer, the dermis layer, the cells are really tightly hooked together. So there's no spaces in between. So the points of access are really those hair follicles are our big point of entry, or even the sweat glands. The sweat glands not so much because of the salty component, right? But those sebum glands associated with the hair follicle, right? Those are what get infected. So what do we call that when that gets infected, y'all? And you really shouldn't pop them. Pimples, zits, blackheads, right? All those things, right? So that's where, like, it's, it's in the skin, it's infecting the hair follicle. And the different colors based on, like, what type of infection's going on. We won't go into that. I don't feel like talking about that today. But I'll tell you this, I'm just as bad an offender as many, like I sometimes can't resist. But think about when you're popping it, right? You're squeezing skin, you're damaging skin cells, and you're releasing bacteria that can go infect other follicles when you pop a zit. That's what you're doing. Even if you clean up after yourself, you're spreading it, right? And you're creating damage when you're doing it, okay? Which can create more spread. What's your best bet, right? If it's not serious, right? You get 1 or 2 zits every once in a while. Non-expired triple antibiotic ointment. I say non-expired because idiot me didn't realize the one in my cabinet was expired. I got a cut on my leg and I put it on and I'm like, man, this is not working. Oh, probably because, it was like, yeah, a few years old. Buy that stuff fresh. It's worth it. You can buy the cheap stuff, right? You don't have to buy the name brand stuff. Okay. It's all the same. Okay. or close enough to the same. The important stuff is likely to save you. Okay. So, all right, that's your skin, which, of course, when it breaks, what do? We clean it with soap and water, and we put triple antibiotic ointment on it, and we watch it. And if it looks like it's not healing, then we go to the doctor, right? And that's what I did. And then they give you topical antibiotics, and when that doesn't work, they give you oral antibiotics, right? That's the way it goes. But we do have openings, right? They are your eyes, yes, your nose, your mouth, your urethra. For us ladies, we got an extra hole. It's called the vagina, and the anus, which that one usually isn't too much of a problem, but, some people like to stick things in that. Usually that's an out-only hole. Okay, but stuff can get in. All of those holes. Why didn't I say anything about your ears? Your ears are not actually connected to your internal environment. They're separated from that by what's called the tympanic membrane, which helps you hear. Right? So there is such thing as the outer ear and the inner ear. Oh, but trust me, Stuff gets there, doesn't it? That's how you end up with ear infections. We'll talk about how it gets there later and why that's a problem. Okay, so how do we protect these openings, right? We bathe them in mucus. What is mucus like? It's sticky, isn't it? It's sticky. It's gooey. It's meant to be sticky and gooey, right? And wet. And it's meant to actually trap the microbes in it and move them to where you want them to go. And to create a layer above the layer of your cells so that hopefully they get stuck in the mucus and they don't make it to you, right? So it prevents them from attaching to us, right? Allows us to put them in this goo and push them to where we want them to go. And depending on what type of mucus you're talking about, it may also contain antimicrobial substances that can directly attack and destroy those microbes, right? And then you have, yet again, competitive exclusion. So like your nose, oh yeah, teeming with bacteria, right? But again, we've got an agreement with most of those guys that are there. It's when the bad guys get in, we run into a problem, right? In those areas. So antimicrobial substances. So these are some of the ones we need to know. So lysozyme we talked about previously. See if you remember it. Defensins are new and lactoferrin are new. So defensins, these are proteins, right? Or, short peptides, amino acids. And they can insert where? Into the membrane. So remember, a cell, whether it be a bacterial cell or a fungal cell, some other invading cell, right? If we can disrupt their membrane, then we can kill them. But again, this is not a very specific response. Pretty much any membrane that's foreign that it can insert into, it will. It doesn't care who it is, just as long as it recognizes it being different. So see, this is non-specific. Lysozyme, on the other hand, which there's a clue here, it's more effective against gram-positive than gram-negative. Why? How do we determine gram-positive versus gram-negative? Remember I said I'd never shut up about that? I wasn't kidding. What do gram-positive have that make them gram-positive when we stain them gram-positive? A very thick layer of peptidoglycan. Guess what lysozyme degrades? Peptidoglycan. So that's gram-positive. Why are gram-negative tend to be it's less effective, they're protected? Oh, they got an extra membrane before you get to the peptidoglycan. We call that membrane the outer membrane because it's the outermost membrane, right, for that bacteria. Thank you for making it an easy name, right? We'll thank that microbiologist. Okay, lactoferrin. We can pick this one apart and figure out the answer. Ferrin refers to an element on the periodic table. Which one? Iron. Lacto means to lactate. So you think about things like milk, but also secretions, right? So like tears and saliva, right? And this mucus stuff we're talking about, those are all secretions. So this one was obviously found first in breast milk, right? Hence the name, lactoferrin. But it's a protein, and we're going to talk about a few more of them, but this one you secrete, right? So not only in the breast milk, but, in your saliva, in your mucus, and it binds to iron, and it helps keep it away from the microbes. Why would we want to keep it away from them? They need it too. Just like we need iron, right? And where do we need iron in the greatest concentration? In the part of the hemoglobin, right? Which is that special protein in the red blood cells that helps us carry oxygen. It is actually the iron, literally the iron that binds to the oxygen of that protein. But they need it for their metabolism too. So if they can steal it from us, they'll do it, right? So we don't want to let them do it. So we block that, right? So these proteins, by binding to the iron, stop them from grabbing it. Does it stop all microbes? No. Some of them, of course, found their way around this system, right? Okay. So what openings do we need to protect? This is a review. I've already said this, right? What are openings to our body? Start from the top. Your eyes, your nose, which leads to what system? Respiratory system, right? You're actually supposed to breathe through your nose, y'all. It filters your air, helps protect you. But you know, breathing's really important, so backup is you can breathe through your mouth. But the mouth is actually the entry into what system? Digestive system, which is actually considered an external environment. It's a hollow tube that goes right straight through your body. And as long as something goes in one end and out the other, it's okay. Right? It's when it escapes from the digestive system into the body that creates problems. Right? Okay. Then we got one more that we tend to squish together. Right? Because for guys, it's definitely squished together. We call this the urogenital system. Right? So, reproductive, genital, right? Uro referring to urine, right? For guys, that's one thing, right? For ladies, that's two things, right? Make sense? Right? And remember, digestive system, mouth is the entrance, and what's the exit? It's called the anus. Yes, it is. That is the proper term for the butthole. Okay. So this is a really good table, but it's like microscopic, right? But the only reason why I leave it up there, right, in this small form, is to let you know that it contains lots of really good information. But we've already started going through this list, right? And you can kind of see that lysozyme is in a lot of this mucus stuff, right? But let's talk about some other components of it. So mucus, as we said, traps, right? So anyone know what the mucus that your tears produce is called? It's actually given a special name. We don't call it mucus. We call it that your eyes produce. I think I already said it. Quit crying. Tears. Tears, right? You ever tasted your tears? Oh, they're salty. Right? But those tears that you produce, mechanically, how you remove the microbes that are constantly basically hitting your windshield, right, of your eyes, is you're constantly blinking, right? And you will keep blinking while I'm saying this too, right, because you can't help it. And that fluid that we call tears, right, that mucus, goes into little tiny channels right next to your nose, called your nasal, like your tear ducts, but they have a anatomical name, which I'm getting stuck on right now. Because they lead to, guess what? Your nose. Your tears goes into your nose. Like, not only is it next to your nose, it goes into your nose. Hold on to that for a second. Okay. Digestive tract, right, is meant to digest food, which is a good thing. This helps us, right? But how do we move stuff through that system? And thank God we don't have to think about it. So that would take a lot of effort. How do we move stuff through the digestive tract? Y'all know this. It's all muscle, right? What kind of muscle, though? Smooth muscle, which is involuntary. So do we have to think about it? Thank God, no. Sometimes I want to, though. Make it go. You just can't make it go. And we call this parasitolysis. But it's muscular contraction, right? The whole chute is one big muscle, basically. Right? We push it out, literally. Respiratory tract. This is a little bit more of a problem, right? We inhale things in. How the heck are we going to get them back out? We can trap them in mucus, but we need to move that mucus out of the respiratory tract. How the heck do we do that? You could cough. Man, we'd be coughing all the time, let me tell you. I get tired. I don't know about you. So there's got to be some other way, right? Coughing is under extreme conditions when we're really trying to get this stuff out. But the rest of the time, you have specialized cells that have little projections to them. We call these projections cilia, and they beat and they move the mucus out. Guess to where? Yeah, think about it. Your throat. Hence the coughing helping, right? But in this case, most of the time, it goes into your digestive system, right? All that crap that gets into your lungs that you sweep back out, right? Trapped in the mucus, you actually swallow and go down your digestive system. This is why people who spit piss me off, right? Because you're supposed to be swallowing that stuff, right? Because what could be in that spit? Pathogens. And you're exposing me to it and others to it when you spit. So spit where you're not going to expose it to someone else if you just have to do it, right? I don't say anything to strangers anymore because my husband's afraid I'll get beat up. But I get really upset when you spit on sidewalks and spit where other people are going to get exposed to it. Huh?
Don't go watch a road race.
Don't watch a road. Oh, God. Yeah, I can't do it. Okay, so urogenital tract, right? How do we get stuff out of there? Well, let's think about the urinal system first. Urination, right? That's the easiest one, right? How do you get it out of your system? You literally pee. Right? And for us women, the good news is we have ciliated epithelial cells too that will clean out that system as well. Right? So if your pee is bright orange, orange. Wow, orange means you took an antibiotic, by the way, probably rifampin. That was fun, but not. Okay, if it's very yellow, right, and smelly, it's very concentrated, which means you haven't been doing enough what? You haven't been drinking enough water. Drink more water, right? The more often you pee, the more likely it's not going to stay in your bladder. It's not going to travel up your ureters, and it's not going to affect your kidneys. Drink lots of water. And pee, right? It's important. If you drink lots of water and you don't pee, you'll die of water toxicity, right? So, water, pee, water, pee. If you have trouble doing that, by the way, put one of those pretty water fountains, you know, those, they call them decorations, right? In your living room or wherever you sit more often, that running water, you'll drink more water and you'll pee more often. I can guarantee you that. I had to move that sucker. It was driving me nuts. All right, so this is physically how it happens, right? We have cells, right? This is the old picture from the first version of your book. The new picture in the new book is better. It actually looks like a goblet, right? That's why they're called these cells, goblet cells that produce mucus, because they look like a goblet, right? Like a glass goblet. They produce the mucus, right? The ciliated cells move the mucus in the direction we want it to go, right? And hopefully that mucus has trapped those pathogens, right? And is moving them out of the system somehow. So, other than lysozyme and defensins, what's also chemically protective? So, I already said your tears taste what? Salty. Your digestive tract. Well, what the heck is the job of the digestive tract? It's to digest your food. So, if a bacteria goes through that system, does your digestive system care that it's a bacteria? No, to them, they're like, if I can digest it, it's food, right? So how do we digest our food? Anyone know? Acid in the stomach helps break down proteins and will kill some bacteria. Enzymes are the big thing, right? And when it comes to fats, we need something your liver produces to help emulsify them in that liquid that you put in your stomach to help digest food. Bile. Salts. They emulsify fats. All of this is destructive to most bacteria. Notice not all, because we still get infections, don't we? Right? Some of them can resist the acid. Some of them are not destroyed by the enzymes. Some of them are not affected by the bile salts. Your urogenital system. So, think about urine for a minute. Unless you have a bladder infection, your urine is actually sterile. Right? It's okay if someone pees on you. See, I told you I'd get you to laugh this morning. Yeah. Was that whole getting stung by the jellyfish? Y'all, how many shows has that been in? I'll pee on you. I know it's not true either. But the good news is if they feel they need to do it, if they don't have a bladder infection, it's A-okay, right? But so we pee to get rid of waste. What are the kind of waste that we would get rid of? Nitrogen, nitrate. Your pH in your blood has to stay within 7.35 or 7.45. You go below or above that and you will die. You either convulse or slip into a coma and die. One of the ways you regulate that is you put the excess hydrogen ions, right, into your urine, or you pull them out, right, and don't let them go into your urine by your kidneys, right? So your pH will vary quite a bit depending on what's going on in your body metabolically, right? And so the pH, that varied pH all the time in your urine, is also antimicrobial. For women, we have normal bacteria in the vagina that produce a lot of acid too, which is antimicrobial. Yes, it's an acidic environment. You can thank the bacteria for that. But it's good. It protects us. Again, that's that symbiotic relationship, the good bacteria that don't cause infection, right? But help protect us. So how do we limit iron availability, right? So one, we already talked about lactoferrin, right? We want to keep iron for ourselves, right? And keep it away from them, right? Because they need it to grow. We need it, as we've already said, definitely for hemoglobin. And you also need it to transport oxygen in your muscles. So there's several types of molecules that we produce that actually keep iron away from microbes. Hemoglobin, right? That's not why we make hemoglobin, right? We make hemoglobin to bind to oxygen, but because it needs iron to bind to that oxygen, it keeps the iron away from the microbes. Not all. And I ran real quick to the microbiology lab, but unfortunately none of the plates from yesterday came out right that I wanted to show you. Damn it. But remember I talked about beta hemolysis, clearing of the red blood cells, right? There are some bacteria out there that will completely lyse red blood cells. Why? They're after that hemoglobin because it's got iron in it, right? Some of them will completely lyse beta hemolysis. Others will poke little holes in the red blood cells to get at that iron, right? Myoglobin, as the name implies, myo in this case refers to muscle, not fungi, right? This is a special protein, again, binds oxygen so that it's readily available for muscle contractions, right? Muscle, especially heart muscle, yeah, it uses a lot of oxygen, lots of aerobic respiration. Transferrin, as the name implies, there's trans in the name, right? Ferrin, of course, refers to iron. This is found in the liquid phase of your blood called plasma, right? And so when you're transporting iron around your body, it's attached to this protein called transferrin. Transports iron. One, it helps keep it away from the microbes, but it probably didn't evolve that way. It probably evolved due to the fact that iron is not very water soluble. What is plasma? Mostly water, right? So it's actually to help literally transport it. Lactoferrin, of course, as I said, was first discovered in milk that's where it got its name, lactoferrin. But you do produce it in your tears, in your saliva, and some of your mucus, right? And in this case, it's leaving your body, right? And it literally is to keep the bacteria from taking it. And for the babies, again, this is so that they get it and the bacteria don't get it, right? That's why we produce it in our milk. Ferritin is how it's stored inside your cells. And there's a small amount of that in your plasma, but inside your cells, again, because mostly inside the cell is water, right? And so iron needs all these protein chaperones. He has lots of protein chaperones. So I asked you to, question is, did you, right? Look ahead to inflammatory response, right? And how this all works and the different types of inflammatory responses which are not so good. And I asked you to watch those videos, right? And read the next section that we'll be going over. If you hadn't done this part yet, definitely do so, because it's going to be a major topic of discussion of next time. And I was really hoping to start the next one, but we're out of time. So we're not going to do that. But please, they're posted, right? Print them out if you want to. I did this first time to really jumpstart you on this material. But it's really important that you read ahead of time, right? So that you understand what I talk about in class. And you ask me questions if you have them.